Hey math enthusiast, I'm here to go over some notes on perimeter, circumference, and area. So let's start out by defining these terms. My first one, perimeter, is just defined as the distance around a shape. So if I'm given this triangle on the right, my perimeter is going to be the total length of these three sides that make up the shape. Now, circumference is just a special case of a perimeter. It's just the perimeter of a circle. So it's the distance around a circle. Which brings us to our last term, area, which is defined as the space enclosed or inside of my perimeter. So with that triangle on the right, we said the perimeter is the total or sum of the red sides. The area would be all the space inside my figure. So now let's take a look at our formulas for perimeter, area, and circumference, starting with the square. So I'm given a square, all my side lengths are S. Now what we said earlier, in order to find my perimeter, it's going to be the total or the sum of all my sides together. So in this case, in order to calculate my perimeter, it's going to be side plus side plus side plus side. So add up all four sides together. Now we can definitely simplify that and say that our perimeter is just going to be 4 times whatever my side length is. Now, in order to calculate the area, I'm trying to think about how much space is inside of my square. In this case, it's really only 1 unit, but what if my square was split up into smaller pieces? Maybe it's a 2 by 2 square with an area of 4 units squared. Maybe it's a 3 by 3 square with an area of 9 units squared. Or maybe a 5 by 5 with 25 units squared. So what I'm trying to figure out is how many blocks or squares make up the whole area inside, or the space inside. Now, in order to calculate this, I'm essentially taking the number of columns times the number of rows. So it would be a side times side. Well, in this case, since both the units are the same, and I'm multiplying a number by itself, I could just think of it as side squared. Now, moving on to the rectangle, and starting with perimeter, as I said, the perimeter is going to be the distance around. So they give me 2 measurements. We'll say my length is the long side, and my width is the shorter side down here. And in order to calculate my perimeter, it is the distance around. So in that case, I would just have to add up all 4 sides. So it would be a length plus a width plus a length plus a width. Now we can definitely simplify that a little bit and just say that my perimeter is going to be 2 times a length plus 2 times a width. Or you could actually rewrite it as 2 factored out and add your length and your width together. And for the area, I'm talking about the space inside. So we could essentially use what we learned earlier in the square and think about how I multiplied the number of columns by the number of rows. So in this case, if I want the area of my rectangle, it's going to be the width times the length. And moving on to the triangle. So they give me my 3 side lengths, A, B, and C. And the first thing I want to think about is, what is my formula for the perimeter? Well, remember the perimeter is just the distance around. So I would have to add up my 3 side lengths, A, B, and C. So my formula is really just going to be A plus B plus C. Now I don't have any like terms here, so there's really nothing I can combine. So that's it for my formula. And next I want to think about how do I figure out my area inside of this triangle. So one way to visualize it is to kind of draw a rectangle around this triangle. Now if you notice, some shapes should look very similar. So this triangle here should look very similar to the triangle on the inside. And this triangle on the outside here should look very similar to the other piece that makes up the area inside. Now, in this case, essentially what I'm thinking about is the entire rectangle would have an area of length times width, or in this case, base times height. But I don't want the entire rectangle, I really only want half of it. So this is where our formula for our triangle comes in, half base times height, because I'm really only focused on the red area here and not the black. Which finally brings us to the circle. So the first thing I want to figure out is, what is my perimeter? Well, we don't use the term perimeter for a circle, we use the term circumference. So my circumference is going to be the distance around my circle. Now, in order to calculate that, we're going to need to use a new term, pi. So my distance around my circle is going to be pi times 2r, or 2 pi r, double the radius, times pi, or since 2r is equal to the diameter, if you double the radius you get the diameter, we could think of the circumference as being pi times diameter, or pi times d. So in that case, what I'm saying is, if I take this length in my circle, this diameter, and stretch it out about 3.14 times, because that's my decimal version for pi, what's going to happen is it's going to stretch all the way around my circle perfectly. Now, as for my formula for area, it's a bit more complicated. Let's jot it down first. It's going to be pi times radius squared. So let's think about what we mean by radius squared. So we have a radius here, and if I square that, I'm essentially making a square out of that specific length. Now what I want to think about is how many of these red squares would fill up the area of my circle right here. One way to think about it is, well, if we drew a large square that just enclosed my circle and split that up into 4 smaller squares using the length of my radius, what I'm trying to think about is how many of those red squares would it take to fill up the blue area? And the answer is 3.14, however many numbers you want to put after that, because pi goes on to infinity, that many number of red squares to fill up that blue area that is the circle.